Hey guys, welcome to today's video. So let's dive into separable variable differential equations. Sometimes they call it variable separable, but whatever. We know what we want to do. Okay, now consider that you're given a differential equation like this and you want to solve this differential equation. So we have f of x plus g of x h of y dy dx equal to 0. So clearly, if you can look at these differential equations, you are going to discover a way to separate variables. And by separating variables, what do we mean? Check this out. Now, assuming I want to separate the variables from this differential equation, it means that you should be able to group. Okay, there are two major variables I'm seeing here, x and y. So everything about x will be grouped on one side of the equality, and everything about y will be grouped on another side of the equality. So let's try that. So first of all, g of x, then h of y, dy by dx is equal to negative f of x. Okay, so assuming we divide through by g of x, we are going to have h of y dy by dx is equal to negative f of x over g of x. Okay, so that is not all. Remember, we want to keep everything about x on one side and everything about y on the other side. So in this particular differential equation, we are going to now see h of y dy is equal to negative f of x over g of x dx. Okay, can you see now what we have in this particular differential equation is that on the left hand side we have y variables, and on the right hand side we have x variables. Is that okay? So this is not all. Now that you have separated the variables, so we are going to integrate. So we usually integrate both sides according to the variable, okay, of interest that is predominant in a particular side. Now on the left hand side, we are already integrating h of y with respect to y, and on the right hand side we are integrating the f of x over g of x with respect to x. Is that okay? Now when you integrate this particular function, then we'll now see, assuming when we integrate h of y, we get some particular function I of y. Then assuming we integrate the ratio of the negative ratio of f of x over g of x, and we get some particular function k of x. Okay, so remember, after integration you always leave an integration constant. Okay, so this will be the approach that we are going to be using to tackle separable variable problems. After integrating everything about x, remember to leave your integration constant. Is that okay? So this is separable variable differential equations. So thank you for watching this video. Everything about separable variable differential equations is necessary for you to understand, because every other differential equation that you're going to be solving, every analytical method, every analytical approach, every other method, Bernoulli, exact, homogeneous, at one point or another they all fall back to separable variable differential equations. So you need to understand how to solve separable variable differential equations, so that when you get to the points where you need to apply the technique of separable variable differential equations, that is in separating particular variables to different sides of the equality, then you will be able to do that. Now, one of the things that will help you to be able to understand separable variable differential equations is that there's usually a product relationship between the coefficient terms. Okay, product relationship. So between some group of x functions and some group of y functions or any other variable that you may be seeing with. So because of that product relationship, it's now easy for you to split the variables and separate them into the different side of the inequality of the equality. Then you can now integrate and obtain your final solution. So thank you for watching this video. Once again, like, subscribe, share, and hit the notification button to stay updated on future videos. Also leave comments, and if there's any question you would want to ask me, you can feel free to ask. Thank you for watching, and see you on the next video.